Hey everyone, get ready to spin into some serious science because today we're going on a deep dive into the physics of Ferris wheels. You know those majestic giants that grace skylines in amusement parks?
Oh yeah, I love those.
Me too. They have this timeless appeal, But have you ever wondered about the science behind their smooth spins and those thrilling sensations you feel as you go up, up, and away?
It's actually pretty fascinating how much physics is packed into something that looks so simple, just a big wheel going round and round.
Right. And we're going to uncover all of it, like how physics explains that feeling of weightlessness at the top and then that extra oomph at the bottom. Plus, we've got a super cool resource to guide us on this deep dive. It's an educational site from Open Educational Resource, Open Source Physics at Singapore. And get this, they actually have an interactive Ferris wheel simulation.
Oh, wow, really?
Yeah, you can play around with it right on the webpage as we chat. I'll drop the link in the show notes. But it's https://iwanttostudy.org, GlueCage, JS, 02, Newtonian mechanics, 6-circle, JS model, Ferris wheel, JSUI first wheel, JSUI simulation.xhtml.
Very cool. I'm definitely going to check that out.
So this website lists Newtonian mechanics and circle as the the core topics behind Ferris wheel physics. Now, I gotta admit, Newtonian mechanics sounds a little intimidating. Is that just like physics jargon for the stuff that governs everyday motion?
It is. Basically, Newtonian mechanics is all about how objects move and how forces interact with them. Think of like an apple falling from a tree. That's gravity, right? Or a ball rolling down a hill.
Yeah.
Those are all examples of Newtonian mechanics in action. And those same laws apply to, well, pretty much everything around us, including massive Ferris wheels.
That makes sense. Okay, so we've got this giant wheel moving in a circle, but it's not just going up and down, it's rotating. And the website mentions something called centripetal force. I have a vague idea of what that is, but can you explain it in a way that even someone who's never taken a physics class can understand?
Okay, so imagine you're on a merry-go-round, and you're holding on tight as it spins faster and faster.
Oh yeah, I remember doing that as a kid.
What's the feeling that makes you want to hold on even tighter?
Like you're being pulled outward.
Exactly. That outward pull you feel is actually a result of inertia. Your body wants to keep moving in a straight line, but the merry-go-round is forcing you to move in a circle. Now, to keep you moving in that circle, there needs to be an inward force counteracting that outward pull.
Okay.
That inward force is what we call centripetal force. It's always directed toward the center of the circle, and it's what keeps you from flying off the merry-go-round, or in the case of a Ferris wheel, from being flung out into space.
Wow, okay. So in the case of a Ferris wheel, where is that centripetal force coming from?
It's actually coming from the Ferris wheel structure itself. The spokes, the rim, everything is designed to create that constant inward pull on the passenger cars, keeping them moving in a circular path.
That's incredible. And the whole time gravity's like playing tug of war, right? Pulling everything down.
Exactly. You can't escape gravity. But on a Ferris wheel, the interplay between gravity and centripetal force creates some really interesting sensations.
Yeah, that's what I was thinking. So can you break down how these forces make us feel lighter at the top and heavier at the bottom of the Ferris wheel? Like what's actually happening there?
Let's start at the top. Imagine you're at the very peak of the Ferris wheel.
Okay, I'm picturing it.
You've got gravity pulling you down,
Yeah.
as always, and then you've got the centripetal force from the Ferris wheel itself also pulling you downwards towards the center of the wheel.
So both forces are kind of working together at the top.
Yes, and that combined downward pull actually makes you feel slightly lighter. It's not that gravity is actually weaker up there.
Oh, okay.
It's just that the centripetal force is adding to the effect, making you feel a bit less weighed down.
So that's the weightlessness feeling everyone talks about.
Exactly. Now let's go to the bottom of the Ferris wheel.
All right, I'm at the bottom.
Gravity's still pulling you down, of course, but now the centripetal force is acting in the opposite direction. Instead of pulling you down, it's pulling you upwards towards the center of the wheel.
So it's like a tug of war between gravity and the Ferris wheel.
Pretty much. And guess who's stuck in the middle?
Me. I mean, the rider.
Exactly. Gravity's pulling you down, the Ferris wheel is pulling you up, and this creates a greater force pressing you down into your seat.
Uh-huh. So that's why you feel heavier at the bottom?
Yep. It's all about how the direction of those forces changes as you move around the circle.
This is so cool. It's making me want to go ride a Ferris wheel right now just to experience all these forces in action.
Me too. But hold on. We're just getting started.
Oh, there's more.
There's a whole lot more to explore. Like, did you know that the speed at which you travel on a Ferris wheel actually changes depending on where you are on the wheel?
Wait, really?
Yep. It all has to do with something called angular velocity.
Ooh, that sounds serious.
We'll dive into all of that after a quick break.
All right, we're back and ready to unravel more Ferris wheel mysteries. Before the break, you mentioned something called angular velocity and how it affects the speed we travel at different points on the Ferris wheel. I gotta admit, that one really threw me for a loop.
Yeah, it's a bit of a brain twister. But once you wrap your head around it, it's actually pretty intuitive.
Okay, well, lead the way. Break it down for us.
Okay, imagine you're watching a race, like runners going around a track. Have you ever noticed how the runners on the outer lanes have to run faster to keep up with those on the inner lanes?
Yeah, definitely. Even though they all finish a lap at the same time.
Exactly. It's because they have to cover a longer distance.
Right, right.
That's basically angular velocity in a nutshell.
Hmm.
It's the rate at which an object rotates around a central point. And even though all the runners might be completing one lap in the same amount of time, their speeds differ because of the different distances they cover.
So the runners on the outside have a higher angular velocity.
Precisely. They're covering more ground in the same amount of time. Now, let's apply that same logic to a Ferris wheel.
Okay, I'm following so far.
Even though all the cars on the Ferris wheel are moving at the same angular velocity, meaning the complete one rotation in the same time frame, the cars farther out from the center are actually traveling a longer distance.
So, like, the cars at the very top and bottom are moving faster than the ones kind of hanging out at the sides.
Exactly. It's all about the distance from the center of the wheel. And this difference in speed is what we call linear speed.
Wow, I never would have guessed that where you sit on a Ferris wheel could affect how fast you're actually moving.
It's one of those things you don't really think about until you start digging into the physics of it.
But it makes total sense when you explain it like that. You know what else I find fascinating? How these concepts we're talking about, like centripetal force and circular motion, they're not just limited to Ferris wheels. I mean, we see them everywhere in our daily lives.
You're absolutely right. Think about driving a car around a curve. What keeps your car from skidding off the road?
I'm assuming centripetal force has something to do with it.
It does. The friction between your tires and the road provides the necessary centripetal force, pulling the car inwards and keeping it on that curved path. That's why race car drivers have to slow down significantly when taking sharp turns. They need to make sure their tires have enough grip to provide that centripetal force.
Oh, that makes sense. I've always wondered why they slow down so much for curves.
And it's not just cars. Think about satellites orbiting the Earth, or even the Earth revolving around the sun.
Wait, so you're saying the Earth is basically on a giant Ferris wheel ride around the sun?
In a way, yes. The Earth is constantly moving in a circular path around the sun, and the force that keeps it from veering off into space is gravity.
So the sun's gravity is acting like the Ferris wheel structure, providing the centripetal force to keep us in orbit.
You got it. Pretty mind-blowing, huh?
Totally. I mean, who knew that the same physics principles that explain a Ferris wheel also explain the motion of planets and stars?
It just goes to show how fundamental these laws of physics are. They apply from the smallest particles to the largest celestial objects.
It's amazing how learning about something as seemingly simple as a Ferris wheel can open up a whole new understanding of the universe.
Exactly. It's all about making those connections and seeing how these principles play out in the world around us.
You know, I remember at the beginning you mentioned that this website we're using is designed for a range of learners, from primary school to junior college. It's pretty impressive that these concepts can be explained in a way that both a child and a physics student can understand.
It really speaks to the elegance of these principles. They're simple enough to grasp at a basic level, yet profound enough to explain some of the most complex phenomena in the universe.
It's like unlocking a whole new level of understanding about how things work. All right, so we've covered centripetal force, gravity, angular velocity, and even touched on the grand scale of planetary motion. What else is there to uncover about the physics of these magnificent machines?
Well, we've talked about the forces that make a Ferris wheel go round and round. But what about the forces that make it stand up in the first place?
I've never really thought about that. I mean, these things are massive. How do they build them so tall and strong to carry all those people high above the ground?
That's where the magic of engineering comes in. Designing a Ferris wheel is not just about physics. It's also about understanding materials, structures, and how to balance strength and stability.
I bet triangles play a big role, right? Like in bridges and stuff.
You're exactly right. Triangles are incredibly strong shapes because they distribute weight evenly. If you look closely at a Ferris wheel, you'll notice that its structure is made up of countless interconnected triangles.
That makes sense. It's like a giant 3D puzzle of triangles all working together.
Exactly. This triangular framework helps to distribute the weight of the wheel, the cars, and all the passengers evenly across the entire structure.
So it's not just about supporting the static weight, right? The wheel is constantly moving, so there must be other forces at play.
You're absolutely right. And that's where the ingenuity of the design really shines through. The spokes and the rim of the Ferris wheel, they're not just solid pieces of steel. They're carefully designed with specific cross-sections and reinforcements to withstand the constant stresses and strains of rotation.
So they've basically thought of every possible force that could act on the Ferris wheel and designed it to handle it.
Precisely. And it's not just about strength. It's also about ensuring a smooth and comfortable ride for the passengers.
Right. No one wants to feel like they're on a rickety roller coaster.
Exactly. That's why engineers also take into account things like vibration and oscillation. They use sophisticated computer models to simulate how the wheel will behave under different conditions and make adjustments to minimize any unwanted movements.
It's incredible how much detail goes into designing something that seems so simple on the surface.
It's a testament to the ingenuity of engineers and their understanding of physics.
It makes you appreciate the ride even more, knowing all the science and engineering that goes into making it happen.
Exactly. It's not just a ride, it's a marvel of human ingenuity.
So the next time you see a Ferris wheel, don't just see a pretty circle of lights. See a symbol of human creativity, a testament to the laws of physics, and a reminder that there's always more to learn and explore in the world around us.
Well said. I think that's a perfect note to wrap up our Ferris wheel deep dive.
I agree. And who knows, maybe this will inspire some future engineers or physicists out there. And to our listeners, until next time, keep those wheels turning and those minds curious. Okay, so we've spun through a whole lot of Ferris wheel physics, from centripetal force to gravity to angular velocity and even the engineering behind those towering structures.
It's amazing how something so seemingly simple can be so complex.
Right. Like, I always thought Ferris wheels were just about, pretty lights and great views, but now I see them in a whole new light, literally.
Exactly. It's all about understanding the world around us, seeing the forces at play in everyday life.
So let's bring it all home for our listeners. Why should they care about the physics of Ferris wheels? What's the takeaway here?
Well, for one, I think it enhances the experience of the ride itself. Next time you're on a Ferris wheel, think about those forces we talked about. As you reach the top and feel that sense of weightlessness, remember that it's not magic, it's centripetal force and gravity working together.
Yeah, and then as you swing back down and feel that extra push into your seat, that's those same forces acting in a different direction. It's like you're suddenly part of a physics experiment.
Exactly. And it's not just about Ferris wheels. These principles apply to so many things.
Right, like we talked about cars going around curves and planets orbiting stars. It's all connected.
It is. Understanding these basic principles of physics helps us make sense of the world around us, from the smallest things to the largest.
It's like unlocking a secret code.
It is, in a way.
Yeah.
And I think that's pretty cool.
I agree. It definitely makes you appreciate the ingenuity of the people who design and build these things. I mean, they're taking these invisible forces and using them to create these incredible experiences.
It's a blend of art, science, and engineering, and it results in something that's both beautiful and thrilling.
So next time you see a Ferris wheel, don't just see a ride. See a symbol of human ingenuity, a testament to the laws of physics, and a reminder that there's always something new to learn and discover in the world.
Beautifully said. I think that's a perfect way to wrap up our Ferris wheel adventure.
I agree. To all our listeners out there, thanks for joining us on this deep dive. And until next time, keep exploring, keep asking questions, and keep those wheels turning.